classical analysis. Don't be scared by the word classic. This is not say classical music or something. So this is essentially if you are going to work on languages like C, Fortran, which happen to be still in use and widely used still. If you let's see, we can do a quick Google search. Say most popular programming languages 2019. Let's see what we have. Okay, we can just pick any random ranking here. This one is on the table. I don't want to on the table. This one is probably a table. Okay. You can see that certainly this is 2018, probably little change here. But still, Python and Java are really popular. JavaScript is popular. C# is popular. So you can see that the C programming language is still up there with C++. So there are actually certainly more jobs involving Java and Python at this day and age, simply because we have so many applications we need to develop. But at the same time, C is still a major force in programming languages. So in that case, this is now something. So you can't just learn, say, oh, I only want to learn object-oriented approach, which you can use in Java, you can use in JavaScript, C#, C++, Object-C, Swift, and all these things you can use. But once you come down to programming, the system level, so for instance, your kernels, your device drivers, anything related to closely related to hardware, you will have to come to C programming languages. So, but you can see that certainly Python is up there, Java is up there. To be honest, at this time, if you don't have time to learn any other languages, these two would be the best choice to spend your time. They kind of, for different purposes, certainly they could all be used to develop, say, ML applications or websites, backend programming and so forth. But so one is scripting language, the other is the other is compile language. So it's slightly different. But if you don't have time to learn too many, these would be your best choices. Okay. So if you don't know Java, our class will give you the basics. If you don't know Python, I'm not going to teach that in my class. Maybe other class will give you a good idea. For instance, many of our security classes are taught in Java, are taught in Python, which you can get a crash course on Python there. If you're doing quick analysis, text analysis, image analysis, anything that you want to get something going quickly, Python is a good choice. For Java, you still have quite a bit thing you need to set up before you can actually be productive and delivering code that produces results for you. But Python is pretty ready to go. The amount of setup you need is very minimal. You can already produce some results. But once it come to really high performance, then that could be an issue. Then you may want to replace that with Java or C++ in the future. Okay. So that's the main motivation for us to talk about classical analysis is to give you a tool that you can use to program in C or straightforward Python. Right? Python certainly can use more complex features, but you can actually use many of our classical analysis approach to program in Python. Okay, so we are covering the things that you can use. You can use basically in C programming or Python programming. Okay. So these are the approaches. Pretty much we invented, widely used, mainly before 1990s. Okay, so these are things that all happened before 1990s. Certainly, they continue into this day and age because they're still useful, right? After 1990s, object-oriented programming has been a dominating approach for programming. Interesting enough, our department is actually more functional-oriented programming. If you look at our faculty list, we have a lot of people specialized in functional programming. So if you are interested in functional programming, this is probably one of the best places on earth for you to learn enough functional programming. You may may go to other departments you will never heard about functional programming. But this is a place if you're interested in functional programming, you will get quite a bit. And the other place is probably Northeastern University on the other end of the continent. They have a big group on this as well. There are many other groups still going, but these are the one or two of the major largest departments who have so many faculty members specialized in functional programming. So here, this is the things that basically people invented before 1990. That's why we call it classical analysis and classical approach. When we say they are classical, doesn't mean that they are not useful anymore. If you are doing C programming or a lot of Python programming, this is still probably your best friend in terms of doing your high-level design and detailed design. Okay, we basically are going to look at with, for instance, things that you can do in object-oriented programming. I mean, in theory, actually in practice, you can all do with the C programming language with no problem, because your C programming language basically is a glorified assembly language which allows you to do anything and anything you like to do with a computer. So it's very dangerous, but it also, on the other hand, it's very powerful. All right, so you can modify any part of your program. I mean, C program, you can load another program into your C program and run that program. There's nothing that prevents you from doing that. Okay, so essentially, so this is the foundation that we can still go back to. All right, so a quick recap of our specification document. For your specification document, you have to have it one way or another. Okay, if you have no specification document of any sort, then essentially you don't even know what you're implementing. You're basically implementing to implement, right? There are no goals set up, and there's no way people can hold you accountable. There's no way you can hold the customer accountable. Basically, it's just it becomes an ongoing negotiation between you and the customer, looking at the code, looking at the code feature, and say, is this something that you can accept or not? Certainly, if you're a customer yourself, yeah, you can survive with no problem, right? So your documentation is basically for yourself, memory. If you don't want documentation, nobody's going to hold you with a gun and say, hey, you have the right documentation. It's really when you have teams, when you have real customers that's not you, and you don't have overriding power over them. So then in that case, you would need some documentation. So they are for two. So your documentation is for two dual purposes. One is for your client, so that you can say, okay, here's what we agree on. Then if I deliver these features, we'll be okay, right? For instance, in our class project, we do have a contract with you. We are not asking anything beyond that piece of documentation, the tags we give you. We also have a pretty clear grading standard for what we are expecting, right? In that case, we are actually setting up a contract with you. Certainly not a formal contract, legally binding and certified by a lawyer and everything. You can sue us if we don't follow the contract. But hey, it's actually close to that, right? So basically, we are not actually adding features, right? Oh, I actually want you guys to send images now instead of just text, right? So if I ask those things, then you can actually say, okay, you don't have in the original contract, that's the uncheck, right? So another thing that is very useful to have a specification is if you have a team. Okay. Right now in our class, I intentionally don't want you guys to work in a team because then we'll have people who program, people who don't program. I mean, how much you program, how much the other guy program, and oh man, I don't want to deal with that. I really want you guys all program the same amount as much as we can, right? So in that case, you are writing this documentation for yourself, and rule of thumb for judging your specification again is, can you share your documentation with another student in the class? He or she can actually go ahead to continue to our next stage. Okay, rule of thumb. This is also a rule of thumb of how you should set up your specification document in a team. Okay, there are no mathematical proof for this, but this is just best practice. All right. So, so essentially there is, you can share the documentation with your team, so you can enable more better and efficient teamwork. However, on the other hand, are you all nailed down to using use case diagram and use cases to write your requirement documentation? No, no. That's just one way for us to make something consistent in our class. Okay, we pick this. You show me that you can deal with such a documentation, such a notation with no problem. Because other way of write documentation, they are very similar to this, just a different representation. So you should be able to master that kind easily as well, even if you hate use case diagram. You can use user stories, no problem, right? You can use any format your team come out with, but as long as your team agree to it. But if you come out with something really strange, then that only works for your team. Then the chance that you will be able to share that knowledge or you reuse that experience when you move to a different company, different team, will be fairly low. Okay? So that's why coming to a common representation will also be pretty useful. All right, so this documentation is actually a contract between your client and developer. That's exactly what we have in our class project. And then there are many things that actually could be taken into consideration. We are not, okay? We are taking into deadline into consideration. We have pretty firm deadline for you to deposit that requirement. We don't want to move that deadline just to force you guys into the habit of deliver something working, minimum wearable product in that deadline. So that's something we are considering. We are not really too much concerned about parallel running. We do have two processes running on two different computers or two processes running on the same computer. We do have a flair of that. But we are not really say, okay, you have to reach certain parallel level certain performance level to deliver your product. That's not we are not very strong in that. The portability, we are not enforcing that. As long as you can tell us which platform you compile, we'll go to that platform, meet you there. But basically, your program, if you're not using anything specialized for your particular operating system, then your code should be portable because it's Java. Okay, rapid response time, we are not enforcing that. Basically, if your program takes an hour to come back with a reply, you know you're wrong, right? You actually know you're wrong. So, but if your program is response time is within I think half a minute, I mean, nobody will think it's too slow, right? It is slow. But basically, this should be like instant reply. Why it's called instant messaging, right? It should appear to be instant, right? If not, I mean, we all have our sort of criteria about instant, right? If you come back within a second, everybody will be happy, I think, mostly, right? But if you come back in 10 seconds, I mean, people will feel it's long, right? Half a minute, way too long, but for us, it's okay, right? So for real-time software, we're not enforcing that at all. This is not a safety critical system, right? And this is not the insulin pump, which have to pump insulin into somebody's body at a certain given time. This is not the software Boeing put on their aircraft, right? So in that sense, we are not real time at all. Okay. All right. So in the documentation, a lot of time you have spelled out a set of test cases, which we already give that to you ahead of time. What is our accepted condition, right? So essentially, you basically have to nail that down with your customer. Say, under what condition, if I pass all these tests, do you take my software? Okay, do you take my software? So essentially, so that's why test-driven development has become pretty popular, right? If you have a set of test cases that can run, and if you say, okay, this is a set of test cases, if it runs, then that software is acceptable, then pretty much that's relatively easier to meet the requirements, right? Cleaner. That's why we want you to set up test cases for your quizzes first. For instance, you are adding a new function to your class, for instance, your tray, binary tray, we have been working on that for the last couple times. Then you should try to come up with a test case, call that function first, right? For instance, if you're going to say, oh, I want to add a function to figure out the maximum depth of my tray, right? Because you already have your tray structure. You have your constructor of the tray, you have a way to populate your tray. So the first thing you do is write a test case which construct a tray from data. How this data is constructed, up to you. It can be something to some array you feed into your tray constructor, or it can be something you get from the standard I/O to construct your tray. Then you immediately call this function on the tray to see whether you can figure out the maximum level or not, right? If you give a certain tray, the constructor a certain tray input data, then you should be able to figure out the depth of the tray. Then you can check the return value of that function is equal to your expected return value or not, right? So in that case, you have your test set up already. When you declare that function, a maximum depth function in your tray structure, tray class, then you run this test. What's the result? What is the result? When you just declared maximum depth function for your tray class, and then you set up your test case to be a constructor of the tray, then you immediately call that function. What will happen? I'm going to implement my maximum depth function or method of my tray, binary tray class. I haven't implemented anything yet, but I already set out a test, which is a constructor constructing a tray, and immediately call that maximum depth function. What will happen?
Fail the test. It should fail the test.
It should fail, right? If it passed, that will be strange, right? So then, if it passed the first time, you know your test case is set up wrong, okay? So it should fail. Actually, that's expected. This is the beauty of test-driven development, right? You have a clear goal set out you want to reach, okay? The best kind of acceptance condition would be a set of test cases like this. You negotiate, agreed on with your customer. Then you have a clear goal of, if I pass this set of test cases, my software is acceptable, okay? So for instance, this tray method, maximum depth method, when you run it first time, it's failed. When you are adding the functionality to this tray structure, to the method, it's keep failing. Until you add enough feature to it, it passed. Then you know you have an implementation of that maximum depth method, okay? Certainly you can't just do one test, you have to do a bunch of tests. Then if you think, okay, I I have looked at all the corner cases of this function. For instance, if the tray itself is actually empty, there's nothing in the tray, or the tray is like a linked list, there are no branch. If the tray have weird so a lot of branches, and all these things need to be taken into consideration. All right. Okay, this is accepted case. Then, for any kind of for most application scenario, for instance, your chat app, if you guys are not talking to each other, not copying each other's code, I'm pretty sure I'm going to get 16 different implementation of the chat app. Okay? So any of the application, any of these applications would pass our, I expect all of you pass my acceptance criteria. Right? So what does that mean to you? I mean, 16 people will have 16 different implementation of the same thing. Why is that? Why is that the case?
Because our brains are wired differently?
That's definitely true. That's definitely true. Mainly because the solution space is not singular. It's not this is not elementary school or middle school math problem. There's only one solution for some problems. This is actually a practice. Practice is a lot messier than textbook. You will actually come to 16 different solutions. Okay? So that's why you actually going to be facing this problem. This is actually going to be determining who is a better programmer or who is a better designer. So our class, we are not the judge. We're not the judge for a lot more efficient design, a lot better design, slightly better design, or something like that. For me, this is elements of software engineering. My job is for you to be able to write